Good morning, Algebra 1. Mrs. Latham here. We are now going to be moving into Unit 6, which is our final unit for our curriculum. And this is section 6.1, which is graphing systems of linear equations. I'm doing something a little bit different this time around. I'm actually going to be showing you how I type my answers into a slideshow to hopefully help you all out with completing your week 2 online learning slides. So I'm going to go through some vocab. I'm going to go through this quickly. So if you want to write any of this down, please just pause the video. First thing, systems of linear equations. I abbreviate it as SOLE, SOL. It is two or more linear equations. So we're looking at two slope-intercept form, standard form, point-slope form equations, any combination of those two, and we're going to graph them. So a solution is any ordered pair that makes all of the equations in the system true. We're going to be looking at three special cases with this. We have consistent. That's when a system has at least one solution. And then inconsistent, when a system of equations has no solution. Independent is a consistent system that has exactly one solution. And then a dependent is a consistent system that has infinitely many solutions. So we're going to kind of figure out what those are. So what we're going to have to do is we're going to be given equations where we're going to have to graph and then check our solution. So if you notice, I have y is equal to x plus 2 and y is equal to 3x minus 2. I'm going to start off by graphing my purple line. And what I'm going to do is I'm going to line up the tip of my arrow with my intercept. So my intercept is 2. That's my b value. And then my slope is 1. I'm going to make it a point to click and drag this and try to line up this line so it ends up having a slope of 1. If you notice, that's the line I get. And now what I can do is I can actually click and drag this. That way it's more centered. And if I want to, I can actually extend out my line. That way I kind of get a really nice line that is that slope. Okay. For the blue line, I'm going to start the tip of my arrow at -2. And then I'm going to use the slope of 3. So if you remember, that's going up 3 and right 1. So I'm going to have to move it a little bit. So we want to go up 3 and right 1. So 1, 2, 3, right 1. There we go. And then I can actually extend this going down. So down 3, right 1. So that's what we get. And if you notice, what's happening is because they have different slopes, we end up getting a point of intersection. So I'm going to kind of draw a little circle there for you guys to see. So that's our intersecting point. So that's where the whole checkpoint comes in. So if I look, this looks like it is the point 2, 4. We don't want that underlined. Okay, so to check this, I'm going to plug this point into both equations. So I'm going to do the purple equation first. So my y value is 4 is equal to my x value is 2 and then plus 2. If you notice, if I do 2 plus 2, I get 4, so I get 4 equals 4. So that means that is a solution. When you get the same number equal to each other, they're the same solution. Let's try the blue line now. So my y value is a 4 again, and then I have 3 times 2, that's my x value, minus 2. 4 stays, 3 times 2 is 6, bring down my minus 2. 4 is equal to 6 minus 2 is 4, so 4 is equal to 4. So both equations work with this point. So the reason why we checked it is to make sure that our graph is correct, which it is, and so we are good to go. It works. Also, side note for this, using the vocab words that we had, because it is a one solution, we could say that this is independent. And independent is automatically consistent. Okay? Part of the definition, right? Independent is a consistent system, so it automatically becomes consistent. Okay, let's do another one. So for this one, again, they're both in slope-intercept form. I'm going to graph this bluish one first. We're going to start at 4, and then the slope is up 2 over 1. So I'm going to change this so it's up 2 over 1. And then I'm going to just kind of extend it out, make sure I'm still following the up 2 over 1 pattern. Remember, up 2 over 1 is the same as down 2 left 1. Sorry, I was blinking on that a little bit. And then I'm going to do the green line. So that's at 2 with a positive slope of 1. So I'm going to change the direction. We're going to go up 1 over 1. I could also go down 1, left 1. And so you're just really going to have to eyeball this. That's kind of what happens. Okay, so if you notice, we have a point of intersection, and it looks like for the most part that it is at, hold on, the point -2, 0. So that's our point. So to make sure that point actually works, let's plug it in. So I'm going to do that bluish equation first. We have that y is equal to 0, and then we have 2 times our x value is -2 plus 4. And if we do the math out, right, 2 times -2 is -4. And then we're going to add 4. And if you notice, we get 0 is equal to 0. So that works for that equation. But now we have to check the green equation. Just because it works for one doesn't mean it's going to work for both. So again, 0 is equal to -2 plus 2. -2 plus 2 gives us 0, and 0 equals 0. And notice this is also independent, which means it is consistent. Now, on your learning slides that you guys will be working on today, you will need to show me the checking for both equations and tell me if it's independent, dependent, or inconsistent. Okay? And I need to see your graphs. You don't have to put the point if you don't want to, but it might be helpful. And I do expect to see this, okay? Looking at this one, so the first one is in slope-intercept form. I'm going to go ahead and graph that first. So I'm going to start at 1 with my arrow. And now it's a half. So that means I'm going to go up 1, right 2. Up 1, right 2. Good. I can even do the trick I was doing before where you put it in the middle and then you kind of like extend it out. Again, just be careful with this because you can mess it up. But on the bright side, completely editable. Okay, for this one, this is in standard form. So we could do 2 things. We could find the intercepts or we could write it in slope-intercept form. I think for the sake of this, we are going to rewrite it in slope-intercept form. So to do that, I have to move my x. So to move my x, I'm going to add x to both sides. So I should get left with 2y is equal to x plus 2. And then the last step is to divide every single number by 2. So if I do 2 divided by 2, I'm left with my y. And then x divided by 2 gives us 1/2 x, right? There's a 1 in front of that x there. And then 2 divided by 2 gives us 1. So if you notice, we have the same exact equation as up top. So that means this line is going to go right on top of my other line. So I'm going to kind of line them up. There we go. So they are right on top of each other. So if you notice, we don't have a specific point to check because they're overlapping. So we would put, so this is an example of infinitely many solutions, right? So there's more than one solution. And if it is IMS, then that would make this consistent, but also dependent. So this is a consistent system. Remember, that's at least one solution, but because it's infinitely many solutions, it becomes dependent. They're relying on each other. So they're actually the same equation, just written differently. Then for the last one, both in slope-intercept form, the first one is starting at 2, and our slope is up 2 over 1. So up 2 over 1. Let's bring it down. So down 2, left 1. Awesome. And then for the other one, we're going to start at -1. If you notice, it has the same slope. So I'm still going to go up 2 and right 1. And we'll go down 2, left 1. So what you notice is these end up becoming parallel lines. They are not overlapping anywhere. Okay. So this means they are no solution. I could write that as NS. But more importantly, this is the word inconsistent. Okay, so inconsistent when there's no solution, meaning they are parallel. So let's kind of recap everything. So a one solution, okay, is when we have two lines. So there's my first line. Got to add my arrows. So that is when we have two lines. I'm going to copy and paste, draw a different one, maybe make it a different color. And they are intersecting. So they are intersecting at exactly one point on the graph. It could always be different each time. They have different slopes. They could have the same intercept if their intercept is where they're intersecting. And then they're consistent and independent. Those are the words we would use. Infinitely many solutions is when we have our line, and what ends up happening is that they end up forming the same line. So they have the same slope, same y-intercept, and they are consistent and dependent. Let's change this. Let's make it like a different line from the other two. Okay? And then the last one is no solution. So no solution is when we have parallel lines. So say we had this line, and then let's do that line, right? So we have two different lines because I just copied and pasted. They should be parallel, right? These lines have the same slope, but they have different y-intercepts, and they're inconsistent. So that is it for our video today. Please reach out and email me if you have any questions. Your homework that's due on Wednesday is the week 2 online learning slides. Make sure those get completed, guys. Really super important. Those are your notes, okay? On Friday, you have Khan Academy due, and you also will have a worksheet which you'll be doing more graphing with. Okay, make sure you hand those in. Make sure you click turn in so I know to grade it and give you feedback before the due date. If you have any questions, please reach out. Have a good rest of your week, guys. Bye.